Hey folks, this is a presentation I gave to a Chicago Python user group a few years back. I wanted to share and have a record of it lying around, so I'm going to record a version of it for YouTube, which you're watching right now if you hear me. I called it a copy-pastable machine learning at the time, and what I think I meant by that is that you could reproduce a machine learning model by simply running all the code. And if that sounds a little bit silly to say, stick around, and I think the pitfalls you might normally see in a machine learning project will make all of this make a little bit more sense than this title implies. So at first, I wanted to give a little bit of my own background just so you guys know where I'm all coming from. Back in graduate school, I did a computational chemistry degree, and while I was there, I even had a bunch of trouble configuring software that I even wrote. We have this supercomputer back at University of Illinois, and it took me about a week to figure out how to install a library that I wrote myself, and that was a huge pain in the ass, and I want to try to help people to not have that problem. And so while I have been working on machine learning pipelines for a bit, I've been doing this professionally for about 3 years now. When I gave this talk, it was about 1. So I might not be the most experienced person in the field, but I do have some opinions, and this is my video, so deal with it. When making models, I try to make my best to make them as reproducible as possible. And this will be more important now with things like the California Consumer Privacy Act and the GDPR that has been in the EU for a couple of years now. And soon the industry as a whole will be facing more regulatory scrutiny. And what does that mean? That means you're going to have to be able to reproduce your results or prove your results in some way, or you might get the ban hammer from the agencies. So I want you to imagine the following scenario. The big boss at whatever corp has recognized that the company is spending a ton of money recognizing stupid cat pictures on your website. So what you do as an enterprising machine learning person, you spin up your little GTX 970 and you got TensorFlow 2.0 running on it, and you start fitting a super deep machine learning model. When your training is done, your results look super incredible, and your process is now super streamlined due to your machine learning, because you're a machine learning person now. And you've been able to save the company like $1 bajillion a year. I mean, just look at that ROC curve. Now, all that's left to do is to re-implement the solution for the production case and maybe have someone review the model just to make sure you didn't do anything wrong. However, when it's time to deploy, we have a problem. The production team can't get your model to work in their system. Additionally, when I tried to reproduce your results, I couldn't get your code to run for like 3 whole weeks. So I have a couple questions for you. 1, how long does it take to recreate the model? Does it take days, weeks, months? And I mean everything from getting the data, to transforming it, to training the model, to doing all your little sanity checks and whatnot. How long does that all take? Including installing the libraries, setting up the computers, all of those stuff. Is the entire process documented in a way in which somebody else, or even yourself, could redo it? Does it depend on weird things about your computer? Do you have some random scripts file in your home directory that is required to run for your entire thing to work? And this includes things like various versions of Python, maybe a different Java version, depending on what you're doing, various files. Even Bash itself is not guaranteed to exist on a computer. Things like Pandas version. So, at the end of the day, what if you wanted to remake it? Instead of me trying to reproduce it, the more likely scenario is that it's going to be yourself, just in a future state. And you're going to forget what you did 6 months from now, or 3 months from now, or 2 years from now, and you'll have no idea. And increasingly, like I alluded to before, with these new regulations, could you answer these questions if a regulator came asking them, and if they had a huge fine lined up for your company that will bankrupt you? And what I'm getting at in general is this sort of reproducibility problem that is really prevalent in machine learning projects. And what I wanted to highlight here is that it's actually not a new problem at all. So many of you have probably already heard that science itself has had a pretty big and publicized problem with reproducibility of experiments in general. So according to this Nature paper I've linked at the bottom here, more than 70% of researchers have tried and failed to reproduce another scientist's experiments, and more than half have failed to reproduce their own experiments. And I can tell you, as a person who used to be an actual scientist, that I believe this 1,000%. So it's clear in the scientific world in general, not just machine learning, we have a problem with reproducing work. And this hurts the scientific process in general, since we don't know if the results are valid if they can't be reproduced. Making matters worse, we could have scientific reproducibility issues caused by subtle software bugs, such as this example I've taken directly from scikit-learn's documentation. While models saved using one version of scikit-learn might load in other versions, this is entirely unsupported and inadvisable. It should also be kept in mind that operations performed on such data could give different and unexpected results. So, you may or may not even notice the problem when you're actually running your code, when you're making decisions about people's lives, and you could be changing things under your nose that you're not even aware about because of silly software bugs. And of course, the big problem that you might come across when you're trying to change a model from a research project into a production system is the "it works on my machine" problem. And this is something that any software engineer is very familiar with, and some data scientists are, but in my experience, very sort of simple problems become a lot harder when you don't pay attention to them, and a lot of data science folks tend to ignore these kinds of concerns. So in the context of a machine learning problem, you might get a thing that can run on your machine, but not another machine because of different Python versions, if you're using Python, which most data scientists probably are. Different versions of libraries, so different pandas, NumPy, scikit-learn, whatever. More subtle problems in like using a C compiler that is different in your different machines could actually cause weird subtle problems. The operating system that you're running all this on is a very obvious one, but again, if you're not thinking about it, you might run into weird problems. If you try to load a machine learning model you made in Windows on a Linux system, you could have really weird results. Other things that you might not think about are things like credentials to your database. So you needed some credentials, I hope, to get the data into your machine learning model in the first place. And so if someone else wants to reproduce what you did, they're also going to need credentials. And if you haven't documented that, it could be really unobvious as to how that all works. And some other things that can happen is the computer you trained this on is a beefy workstation, and the person that's trying to reproduce what you did doesn't have the same computer as you. And if they don't have enough RAM, maybe the entire thing will just crash and burn. And if this isn't documented, it can be a really painful experience. Another thing that happens a lot is problems in just general the deployment cycle. And I got this quote from Algorithmia, which is a platform as a service for machine learning product. It's really cool, but I've never actually used it. This quote from them says it all. The sad reality is the most common way machine learning gets deployed today is through PowerPoint slides. And I can't agree with this more. It's like every other project is basically just some executive bragging to some other executive that they've deployed this thing, when in reality it's not even done yet, and they're just trying to get a promotion. So that's I just thought that was a funny quote. Additionally, what they're saying here is also true. It's not uncommon to have a machine learning pipeline that starts in R, continues in Python, and ends in Scala. Making those all work together is not trivial. So what they're alluding to here is, especially if you're dealing with large data, you're probably going to be dealing with something like Apache Spark to do your data transformations. And that is a Scala tool, which runs on the Java virtual machine. And that can, getting that to work with Python, getting that to work with R, it can all be a little complicated, because they're all dealing with very different runtime requirements of these different tools. So you have to be able to deal with this complexity. In a real project, basically what I'm trying to get at all here is, in a real project, we would like to be able to make models in a way that we can reproduce and in a way that we can deploy. So what I'm saying is that the fact that your model is not reproducible and the fact that your model is not deployable, I think there's actually a lot of overlap in those two things. So when setting everything up, I think there's a lot of overlap between being able to deploy and being able to reproduce. So what if we use deployment tooling to give ourselves reproducibility in the scientific sense? So what I'm getting at here is there's been a ton of work, especially in the past decade, to use in these tooling, the work. Sorry, I can't talk. In the DevOps and operations space, that have been working on trying to deploy things very well. So maybe we can leverage the work that they've done in their operations to make our work more reproducible in the scientific sense. As a side effect, all this stuff can help your experimental iterations go smoother because you've automated all the operational concerns away. And of course, by the time we get to deploy our stuff, since we've done all the operations things, then when we come to deploy stuff, it's a lot easier because we've sort of front-loaded a lot of that work. So let me get a little bit more concrete as to what I mean by all this stuff. So as I alluded to before, the environment that you run your code on can have a lot of implicit dependencies on it. And one way that a lot of the industry has been going to solve this, so, making sure that you have Python, making sure that you have Make or whatever, is to use containerization. And the most popular way to do that right now is Docker, but there are other choices. I'm just using Docker as like the most industry standard version of containerization as I'm recording this, but that might change. Another big problem that you can have in a machine learning workflow in particular is that the entire workflow that you use to go from data to a model is undocumented. And so there's these tools that will codify the workflow, something like an Airflow or Luigi or something like that. There's more lately, such as Prefect or I can't remember. There's like 10 of these now. Scaling, deployment, or training is another problem that you might run across if you have a lot of data or if you need to serve your model to a lot of people. Kubernetes is a great industry solution for allowing multiple nodes to serve or train your model. That's becoming more and more popular over time. And a data lineage is sort of like the last step in my opinion of this whole process. And I'm not going to talk about that because that's like a whole nother complicated thing. And I'll leave that to other folks. So it would be a really nice way to create model. It'd be really nice to have a way to create models that addresses all these concerns. To understand the tool that I'm really here to talk about, I want us to do a quick overview of two things that have become really popular lately. If you're already familiar with these, I'm sorry in advance. So again, if you're a software engineer, you might want to skip the next couple minutes. But if you're not familiar with Docker and Kubernetes, you should listen up. One of the first tools to be familiar with that I'm going to talk about is Docker. And if you have never heard of Docker before, you can sort of think about it as basically a fancy way to make a big zip file that's got all of your code and your dependencies. And when you want to run your code, you just pass this thing called a container, which is just a big bundle of code, and run it on a different machine. And it just works if it has Docker on it. Now, this includes things like your operating system, your programming languages, so you don't have to worry about those things being the same as the system that you're running on. So you get this sort of portability aspect of it. Now, when you start using Docker a lot, you can sort of get this huge boost of confidence that the stuff, whatever you're doing, will behave the same on your laptop. It will behave the same on my laptop and in the production context. And an example document, this is like this very trivial Docker file that you might do, but you can definitely reuse something that looks like this for a very simple model, where basically you're saying, I'm going to start from somebody else's Docker image, they call it, and I'm going to add some stuff on top of it. So I'm going to take this Python 3.7 image, and I'm going to install Matplotlib, Pandas, scikit-learn, Flask, and JSON schema. And I'm going to add in some Guru for logging, and then I'm going to add my code. And then whenever I go to run this stuff, I'm just going to have it run Python on my CLI file. And these things can be written like as you're developing, and when you build them, you can reuse the built image basically anywhere, and it's very trivial to get it up and running. And one of the most popular ways nowadays to actually run these things in a production context is something called Kubernetes. Again, if you've heard about this, you can skip ahead. Basically, at a very high level, Kubernetes lets you deploy containers. So what we just talked about is packaging your code into a little bundle. Kubernetes will help you run those bundles. You might want to have the containers talk to each other. So if you're running a distributed compute job, you want to be able to have your containers network with one another, and Kubernetes can help deal with that. And you might want to scale your copies out. If you have maybe a huge spike in traffic, you want to be able to add more web servers to serve your model, for example. You get fault tolerance built into the system, so if one of your nodes goes down, you can handle that gracefully. You can run locally or on a cloud service provider, and it's got a very large and active open source community associated with it, and lots of tooling. Kubernetes. So I've basically been making the claim this whole time that infrastructure as code is a necessary but not a sufficient condition for reproducibility of a machine learning project. One of the things that you might be scared about when you're talking about Kubernetes is it can be quite complicated to manage and run, and it's just a large beast. In particular, if you have large orgs, though, you can have maybe one team that manages the Kubernetes cluster itself, and many teams use it. So at the place I'm working right now, we have one team that's responsible for keeping the cluster up and running, and then we have dozens of teams that actually use the cluster. So the complexity is sort of managed in one team, and the benefits are spread across many teams. And another benefit that you get from using Kubernetes is you can leverage the open source community to add whatever you want to your cluster. So you might want to add things like a database, so use Postgres, or using things like the XGBoost operator. So if you want to train a model using distributed XGBoost, you might look into something like this, which will handle getting the cluster up and running for you. In conclusion, so what we've talked about today is that reproducibility can be pretty hard, but there's been a lot of people working in other areas like DevOps, and we can use their work to help in our goals of reproducing in terms of scientific and machine learning workflows. And I've talked a little bit today, but probably will go into further depth in the future about Kubernetes, is one such tool we can use to help reproduce our work.